In this video, we are going to learn some basic of set theory. First, the complement of an event. The complement of an event is all comes in the sample space that not in A. So in this plot, everything in the rectangle represents the sample space. The white circle A represents event A, and the complement of A, denoted by AC, is represented by the gray area. Here is two formulas you have to remember. The probability of A happens plus the probability of AC happens always equal 1. Equivalently, the probability of AC happens equals 1 subtract probability of A happens. Remember that the sum of all possible probability must be equal to 1. A and AC would contain all possible outcomes in the sample space. Here is an example about roll a fair 6-sided die on one time. Let the event be rolling a 3. The sample space is 1, 2, 3, 4, 5, 6. And the probability of rolling 3 should be equal to this formula. The denominator is the number of ways to roll 3, which is there is only one way to get 3. And the total number of outcomes in the sample space is 6. So that's why we have probability of rolling 3 is 1 divided by 6. Now let's find the complement of rolling a 3, or what is the probability of not rolling a 3. The probability of not rolling a 3 should be calculated as the number of the way to not roll a 3, which contains number 1, 2, 4, 5, 6. So there are 5 ways to not roll 3. And the number of outcomes in sample space is still 6. Using another formula, using this formula here, we can also calculate the probability of a complement of rolling a 3 in this way. Use 1 subtract the probability of roll 3, which is 1 subtract 1 divided by 6, which is from here. We can see these two numbers are the same. The intersect of two events consists of the outcomes that in both A and B is the definition of intersection of events. The outcomes must be in both A and B, which is represented by the red part in this plot. Here is an example about roll a fair 6-sided die on one time. Let one event be rolling a number less than or equal to 3. Less than or equal to 3 consists of the following outcome: 1, 2, and 3. Let the other event be rolling an even number. Even number consists of the following outcomes: 2, 4, 6. What is the probability of rolling a number less than or equal to 3 and even number? Know that 2 is the only outcome in both events. So number of outcomes in both and less or equal to 3. And even, being even, there's only one way, number 2. So that's why the probability of less or equal 3 and even number is 1 divided by 6. Next, disjoint events. Two events A and B are disjoint if they do not have any outcomes in common. Here, A and B do not have any common areas. Note that the events A and AC are disjoint events. If A and B are disjoint, the probability that A and B happens at the same time is 0, because there is no intersection. Again, this is the example about row a fair 6-sided die on one time. First, let one event be rolling an odd number. An odd number consists of 1, 3, 5. Then, let the other event be rolling an even number. Even number consists of 2, 4, 6. So what's the probability of rolling an odd and an even number? There is no common between this set and this set. Or we say no common elements. So there is 0 outcomes in both odd number and even numbers. So that's why we can calculate this probability as 0 divided by 6. Next, union of events. The union of two events consists of outcomes that in A or B or both. Outcomes can be either A or B or both. The probability of A or B happens equals the probability of A happens plus probability of B happens. Subtract the probability A and B happens. We want to subtract the common area here, because we do want to count the common area twice. Again, this is the example about roll a fair 6-sided die on one time. First, let one event be rolling a number less than or equal to 3. So less than or equal to 3 consists of the following outcome: 1, 2, and 3. Let the other event be rolling an even number. Even consists of the following outcome: 2, 4, 6. So what is the probability of rolling a number less than or equal to 3 or an even number? Here is option 1. Note that 1, 2, 3, 4, 6 is the only outcomes in either event. So make sure you do not count 2 twice. So probability of less than or equal to 3 or even number is the number of outcomes in either less or equal to 3 or even, which is 5, divided by the total number of outcomes. Option 2, we can use the formula and the probability we have already found. The probability of less or equal to 3 is 3 divided by 6. The probability of being even number is 3 divided by 6. Subtract by the probability of less than or equal to 3 and being even, which is 1 divided by 6. We can have same result.